Welcome to the University of Queensland School of Architecture series introducing Grasshopper and Rhino. Now we're going to work through a progressively more complicated set of routines based on the Twisted Tower concept. So the base seed file in Rhino is called Twisted Tower, and I've saved the routines in 3 different stages. But for the videos I'm going to start more or less from scratch, but you can pick up the routines at the end of critical points of the development of the routines. Now in this first development, the stage 1, what I'm going to do is reconstruct the floor slabs and then introduce a progressive twist up through the tower. Now I'm going to start from the similar position from when we did the simple tower, and I'm going to introduce a boundary surface to create our slabs. Now I'll just double check what reference geometry, so I'm going to select that one, right click, set one curve. Okay. So that curve through here is going to then establish our floor plate. So what I'm going to do then is to give the floor some thickness. So I'm going to do an extrude through here, and I'm going to plug in the base geometry through here. Now the extrude distance is going to be a negative value from the floor surface through here to give us the thickness, and not to forget that we need to give it a projection vector. In this case we need to give it a z value, so it projects in the z plane, and we're going to connect those two. So we have then our first floor of our tower. Now what we're going to do is to generate a floor-to-floor spacing, and we're going to do that similar to how we did it in the simple tower. We're going to generate a series, and we're going to use the floor-to-floor distance as the step value for each of our duplications, and the count will be the number of floors in our tower. So that's a fairly simple operation, just to sort of recap where we were from last time. We're going to introduce a move command, and again we need to give ourselves a projection vector. I'm going to connect that into there, connect the distance, and then we're going to duplicate that through there. So now we should have an evenly spaced tower over 50 stories. Okay, so that's the simple thing. Now what we're going to do now is develop the twist in the tower. Now there's probably a lot of ways you can configure the variable, and one way would be to I guess determine the angle of twist per floor. But in this instance I'm going to do a slightly different way, and I'm going to introduce a slider to control the number of twists. Now if you look at a lot of the Twisted Tower precedents, they don't twist more than probably a quarter or even half a twist up through the whole tower. So what I've done with my number slider here is that I've given myself a floating point, which is basically, and I've given it a number of decimal points. So if I just have a normal integer, then I can't, I need to sort of then twist it in whole numbers, so 1 twist, 2 twist, and so on. But in this way I can be a bit more fine-grained, and I'm going to limit my range to 2 twists, because after that it becomes a bit extreme. So 0.25 would be then a quarter twist, 0.5 half a twist, and so on. Now in order to set up the geometry for that, to introduce a bit of simple maths, and I'm going to start with a simple maths operator, a multiplication through there, and I'm going to start my multiplier as the number of twists, and I'm going to put the other factor in as a full twist, as 360 degrees, and I'm going to input that not as a slider but as a panel, because I want to fix that as a number. I don't want it to vary, because I want us to give a step value as a fraction, or as a value relative to one full rotation. That's why I've put a fixed value of 360 degrees. Now, in order to develop, I guess, a step value over the total number of floors, then I'm going to have to integrate this relationship with the total number of floors. So I have, I guess, a percentage value in relation to one full twist, but then I'm going to divide that into the total number of floors, and I'll plug that in through there. So if we open up a panel here, you can see here what we should get is a step value in degrees per floor. So over 50 floors with a quarter of a twist, it's going to rotate 1.8 degrees per floor. Now I'm going to bring this over here. Now the output from here will start to feed into our rotation that we're going to add in, but what I'm going to do is I'm going to associate this panel with the number of twists. So as I vary the number of twists, I can also get a bit of feedback as to what the degree of rotation per floor, to see how extreme it is. Now I can actually put a title on this panel, and I'm going to call this degree rotation per floor, and I'll expand that out a bit so that we can see that. So I'll put that and I'll associate it with the number of twists, so it gives us a bit more information. So I'm going to add that to the group. So I just select it, and then holding the shift key, I'll show you that again. I select that, hold the shift key down, select the group, right click, add to group. Now, just to sort of neaten this up a little bit here, I'm just going to right click on that and show the wire display, oops, here we go, as a hidden line. So that way, although it looks like it's just sitting there at random, it will actually give us some valuable feedback without cluttering up our routine with all these wires going all over the place. Now we're going to introduce a twist or rotation through the tower as in a series of steps. So each time it's going to step 1.8 degrees for each floor. Now to do that, I'm going to have to set up a series, and so that each series will step in increments as we determine according to this twist here. Now, as we might have discussed in other Grasshopper tutorials, the angles in Grasshopper are expressed as radians, so we're going to have to pull up the radians component. So that's, we start off radians, and we can see through here, because we're expressing this output as degrees, we're going to have to input the degree value through here, and we'll get it output as radians. Now what I'm going to have to do is then introduce a series so that we can calculate the step value on each floor. So the step value will be the value in radians, so that's the step value. The count will be the number of floors. So I'm going to then connect that into there. So that's got us set up for how we're going to rotate this. Now all we have to do is plug in the rotate on object around a plane. Now the geometry that we're going to rotate are all of these floor plates through here. I'm going to connect that to that, and it's wanting the angle, which is all of these step values through here. Now as you can see, again, we've got overlapping geometries, and all we have to do there is turn that to preview mode, turn that to preview mode as well, and we can turn that to preview, and what we should be left with is a twisted tower. And if we dial that in different degrees, so that's what it looks like with a full twist, which is pretty extreme. So really anything up to a half a twist is starting to really push the degree of twist that just becomes unbuildable, really, to be honest. So that's got our floor plates rotated, but what we need to do then is to push our cores through the each floor plate as well. Now to do that, we'll going to just do a simple extrude of the two core elements. Now if we just go to here, we can see the core elements are there. I might just turn that off so I can see what I'm doing. Okay, so I'm going to just do a simple extrude. So what I'm going to do first is I'm going to associate these two cores first with this input parameter. So set multiple curves. There we go. Now after I've set my curves, I'm going to figure out how high I want to extrude these cores, and really that's a simple calculation, which is basically the floor to floor height by the number of floors. So I'm going to introduce a multiplier. I'll plug in my floor to floor height with my total number of floors. I'll introduce a Z value through there, and then I'll just use the extrude command through there. So that's the distance that we're going to do, and I'll just plug in the geometry, which is the cores through here, into there. So we've got our cores, but because we've got the 50 stories, we are going to get an overrun, but in this instance we're not going to worry too much about that because most lifts need an overrun. So that's simply our twisted floor plates with the cores running through, and in the next stage what we're going to do is start to look at how we're going to put a skin on this. And as you'll see in the grasshopper seed that is associated with these videos, the routine has been cleaned up, but I'm just going to leave it like this for now. Okay, so we'll check back with you in the next video. Thanks.